The JavaScript Mastery Series. This isn't just another JavaScript tutorial. We're going to learn JavaScript from the memory perspective, understanding how it actually works internally. Here's the complete roadmap: foundation, execution model, functions, objects, async JavaScript, browser, and the document object model, and coding interviews. Today, we start at the very beginning. How JavaScript works internally. From transistors to async code. Let's go! In the beginning, the web was just static HTML files. No animations. No interactions. Just text and links. A document linked to another document. That was it. And it changed the world. When you type a URL, your browser sends an HTTP request across the internet. It reaches a server, a computer sitting somewhere in the world. That server finds the HTML file and sends it back. Your browser reads it and paints the page. Every single time. In the early web, the server did everything. It received your request, fetched data from a database, assembled the full HTML page, and sent it back. Your browser just displayed it. No thinking required on the client side. The web was growing at an incredible rate. Millions of new users every month. Static pages couldn't keep up with what people wanted to do. Forms needed validation. Pages needed updates. The pressure was building for something new. Here's the problem. Every time you wanted anything to change, click a button, submit a form, update a counter, you had to send a brand new request to the server. Wait for a response. Reload the entire page. It was slow. It was painful. And it was limiting. Imagine if the page could react to you. Without calling the server. Without reloading. What if it could validate your form instantly? Show a drop-down? Animate a menu? The web needed a brain. Right there. In the browser. In 1995, Brendan Eich created JavaScript in just 10 days at Netscape. It was designed to make web pages interactive. A scripting language that runs right inside the browser. No compilation. No installation. Just write it and watch it run. That decision shaped the entire internet. Here's a mind-blowing concept. The server sends static HTML. It looks like a page, but it's dead. No click handlers. No state. Then JavaScript loads and attaches event listeners, connects state, wires up interactivity. This is called hydration. The HTML gets hydrated with JavaScript. Dead markup becomes a living application. Then came a radical idea. What if the server sends almost nothing? Just a tiny HTML shell and a big JavaScript bundle. The browser downloads the JavaScript, runs it, and builds the entire page from scratch. Client-side rendering. The browser became the construction site. Your browser is not just a window that shows pages. It's practically an operating system. It has a rendering engine that paints pixels, a JavaScript engine that runs code, a networking layer that fetches data, a storage system, a GPU compositor, multiple processes working in isolation. It's engineering marvel hiding behind a simple URL bar. Inside every browser lives a JavaScript engine. Chrome has V8. Firefox has SpiderMonkey. Safari has JavaScript core. Their job? Take the JavaScript you write, which is human-readable text, and turn it into something the CPU can actually execute. This is where the magic happens. Now we're going to zoom in, past the browser, past the software, into the actual hardware that makes everything possible. From the digital world into the physical world, into the machine itself. Before we go deeper, you need to understand the CPU, the central processing unit. It's the brain of every computer. It can only do incredibly simple things, add numbers, compare values, move data. But it does them billions of times per second. That speed is what makes everything possible. A CPU is made of transistors, tiny electrical switches that can be either on or off. Your phone has over 15 billion of them, each one smaller than a virus. When electricity flows through, it's on. That's a 1. When it doesn't, it's off. That's a 0. Everything in computing starts here. Those on-off switches create binary, 1s and 0s. That's the only language a CPU understands. Every image you see, every song you hear, every line of code you write, it all becomes 1s and 0s. Machine language. Raw instructions that the CPU executes directly. No human can write billions of 1s and 0s by hand. So we created programming languages. Higher-level instructions that make sense to us. Then we built translators, compilers, and interpreters to convert our words into machine code. JavaScript is one of those bridges. You write readable code. The engine turns it into machine instructions. Think about it. Your JavaScript code is just text. Characters in a file. Letters, symbols, spaces. The engine can't run text. It needs to break it down, understand the structure, find the meaning. Let's see how. When your JavaScript file arrives at the engine, the first thing that happens is parsing. The engine reads your source code character by character. It needs to understand what you wrote. What's a keyword? What's a variable name? What's an operator? This is where comprehension begins. The parser breaks your code into tokens. Think of it like taking a sentence and separating each word. Let x equals 10 becomes 4 tokens. Keyword let, identifier x, operator equals, number 10. Each token has a type and a value. This token stream feeds into the next stage. Now the parser takes those tokens and builds an abstract syntax tree. The AST. Think of it as the DNA of your program. Every operation becomes a node. Every value becomes a leaf. The tree captures the exact meaning and structure of your code. This is what the engine actually works with. Here's where it gets interesting. Traditional interpreters execute code line by line, slow but flexible. Compilers translate everything up front, fast but rigid. JavaScript engines use both. Just-in-time compilation. They interpret first, then watch for hot code paths that run frequently, and compile those into optimized machine code on the fly. Best of both worlds. Let's trace the exact path inside V8. Your source code enters the parser. Tokens become an AST. The AST feeds into Ignition, V8's interpreter, which generates bytecode. If a function is called many times, TurboFan, the optimizing compiler, kicks in and compiles it to raw machine code. If assumptions break, it deoptimizes back to bytecode. A continuously self-optimizing machine. Now the engine executes. It creates a global execution context, hoists variables and functions, then runs your code top to bottom. Each line triggers operations, memory allocation, computation, function calls. The CPU is doing exactly what you asked. Your high-level human thoughts are now electrical signals racing through silicon. The call stack is how the engine keeps track of where it is. When you call a function, a new frame is pushed onto the stack. When the function returns, the frame is popped off. If you call too many functions without returning, like infinite recursion, the stack overflows. That's the famous Stack Overflow error. The JavaScript runtime is more than just the engine. The browser provides web APIs, timers, document object model manipulation, fetch. When an async operation completes, its callback goes to the callback queue. The event loop checks, is the call stack empty? If yes, it moves the next callback from the queue to the stack. This is the complete runtime. Engine, APIs, queue, and the loop that connects them all. JavaScript is single-threaded. One call stack. One thing at a time. But it never blocks. While waiting for a network request, it keeps running other code. The event loop, web APIs, and callback queues create the illusion of parallelism. Promises. Async await. All built on this foundation. You now understand from the very bottom, from transistors to async JavaScript. That's the complete journey. From silicon to software. You just went from transistors to async JavaScript. You now understand how the engine works from the inside. But this is only the beginning. Next episode, we dive into the memory model. Stack versus heap. How JavaScript stores your variables. Where primitives live. Where objects live. Why some copies work and others don't. Understanding memory is understanding JavaScript. See you there.